This is a regular pentagon with a side length of 4. What is the area of this pentagon? Let me show you the new method I have discovered. The principle is so simple. This is the formula for the area of a regular pentagon. This represents the side length. Since the given side length is 4, using this formula, we get this result. Now, let's derive this answer using my new idea. Extend this line in both directions. Draw a line passing through this vertex that is parallel to this line. Draw the lines passing through these vertices that is perpendicular to this line. This shape is a rectangle. The area of the pentagon is the area of this rectangle minus the area of these 4 parts. However, the pentagon is symmetric with respect to this axis. Also, this line is parallel to these lines. These 4 right triangles are congruent. Therefore, the sum of this area and this area equals the area of this rectangle. Now, draw the lines passing through these 2 points that is perpendicular to this line. These 4 right triangles are congruent. Thus, the sum of this area and this area equals the area of this rectangle. The total area of these parts equals the total area of these 2 rectangles. Look at the picture. The area of the pentagon is the area of this rectangle minus the area of these 4 parts. And the area of these 4 parts equals these 2 rectangles. So the area of the pentagon is the area of this rectangle minus these 2 rectangles. Eventually, we've got to the stage where we can calculate the area of a regular pentagon. It is the area of this rectangle plus the area of this rectangle. Now, let's determine the areas of the 2 rectangles. This length is half of this side, so it is 2. We need to find the lengths of the remaining 3 sides. In a regular pentagon, the diagonal length is obtained by multiplying the side length by the golden ratio. According to this formula, the length of the diagonal in this figure is 2 plus 2 root 5. Since this forms a right triangle, we can use the Pythagorean theorem to find its length. This is the length of this side. This side is also a diagonal of the pentagon. Thus, its length is also 2 plus 2 root 5. This length is half of this side, so it is 1 plus root 5. This length is 2, so the length of this segment is 1 plus root 5 minus 2, which simplifies to root 5 minus 1. Since this forms a right triangle, we can use the Pythagorean theorem to find its length. This is the length of this segment. Now we have determined all the dimensions of the rectangles. The area of the pentagon is the area of this rectangle plus the area of this small rectangle. The area of this rectangle is this length times this length. The area of this small rectangle is this length times this length. Adding the 2 values gives the answer. Let's simplify the expression further. This expression can be rewritten like this. However, this answer doesn't match the value we originally obtained using the formula for the area of a regular pentagon. But it doesn't mean that this answer is wrong. Please factor out this value. Perform the calculations. We have the final answer. This completely matches the value we got. This is the correct answer.